Hello, welcome to Marsh Mathematics, and this video on differentiation is about the product rule. Okay, now one of the examples I've picked here is a typical exam question, and I've written it out so that I can talk through it. Okay, now if they're going to give you a question on the product rule in an A-level exam and it just involves the product of two functions of x, they're going to make it quite difficult. Okay, so let's just remind ourselves, how do I know it's a product? Well, they multiply together two functions of x, u being x cubed and this bracketed term to the power of a third being another function of x. Okay, so if we've got two functions of x multiplied together, we can actually find dy by dx using this formula. Now this formula you need to remember, okay? The quotient rule, which we do in the next video, they give you that in the exam, but they don't give you the product rule, okay? So once we recognize that it's it's a product and that we need to use the product rule, okay? So they've given us an expression for dy by dx. We need to be able to prove that, okay? So it's quite tricky algebra to do this. So the first thing we do is we let u equal x cubed, and we differentiate that because we need u and du by dx, okay? Then the next term, we let v equal the bracketed term, okay? And when we differentiate that, this is actually the chain rule. If you think about this now, how I've found it is because if I had the chain rule, dy by dx is equal to dy by du times du by dx. So what I've really, if you let the bracket really be u there, this and du by dx is the 3, you see. So when I differentiate it as if the whole bracket is u, and that's what I get, a third, and then the bracket to the minus 2/3 because you take 1 off the power, and then you just times it by the differential of what's inside the brackets. So that's a quick way of doing the chain rule, you see. Okay, now so they do try to involve the chain rule within the product rule in an exam type question. Okay, so that what we do now is you substitute all these terms into this rule here, the product rule, and we end up with this. So okay, I don't know how many marks this is for, but we get some marks for that. But the difficult thing is proving this, okay? And it's a bit of a tricky factorization, because if you notice we got dy by dx is equal to this now. So how do I get it to look like this? Well, if I notice, I need to take an x squared and a 1 plus 3x to the power of minus 2/3 outside. So it's okay for this because we're just taking x outside. But how do I factorize this? Well, if you write this as 1 plus 3x to the power of 1 times 1 plus 3x to the power of minus 2/3, you can see how they've done it, you see, because you can now take this outside of the bracket, okay, and the x squared, and that leaves 1 plus 3x inside the bracket. So that was a very crafty factorization there, okay? It doesn't look like you can factorize it, but you can by writing this in this way, okay? So, and that's how we get to this expression. So that was quite tricky. So why do we want it in this form? Because that gives us this. When we can write it in this form, we can find out where the turning points are. Writing it it'd be more difficult writing it in this form to find the turning points, because we need to know when dy by dx is equal to 0. So at the bottom here it says find out the turning points of this curve. So at the turning points, or stationary points, dy by dx is equal to 0. So if I rewrite that, remember that because it's a minus power, we can put that on the bottom, okay? This term here we can put on the bottom. And so for this to be equal to 0, the top part must be equal to 0, not the bottom. The bottom cannot be equal to 0, okay, because it'd be infinity. So for that top part to be equal to 0, then either x is equal to 0 or x is equal to minus 3/10 or minus 0.3. Then all we need to do is to substitute these values, x equals 0 and x equals minus 0.3, back into the original equation at the top there, up the top, the original equation at the top, y equals x cubed, this one, just substitute it in there and we get the two y values. And just because it's an awkward question, it doesn't actually come out to be exactly, you don't get an exact value for the y value when we substitute minus 0.3 in, so I've given it to 3 significant figures. And so there we go.